Hello physics students, here is the teaching video and kind of going over this practice with the free fall worksheet. So number 1 says a professional baseball pitcher throws a baseball straight up into the air on the edge of the Grand Canyon. He throws the ball with an initial velocity of 40 meters per second, which is almost 90 miles per hour. Letter A, draw a picture showing the position of the ball at each time interval, each second, and label the velocity at each time interval, and show the distance the ball rises or falls. Note, in this chart, use a negative in front of the velocity when the ball is falling. In the chart, use a negative in front of distance when the ball is below the edge of the Grand Canyon. Okay, so here's our Grand Canyon. And here's our person throwing the ball. Okay. And my velocity here is 40 meters per second. And this is my time equals 0 seconds. Okay. So the ball is going to go up some distance, we know. And because gravity, sorry about that notification here. Okay. Because gravity is 10 meters per second squared, it is going to decrease the speed of this each second by 30. So I know up here, the ball is going to have a velocity of 30 meters per second. And now this is my time of 1 second. So the ball is going to rise again because it's continuing to grow up. And now the velocity is going to be 20 meters per second. It's losing because gravity is accelerating it and pulling it down. And this is my time equals 2 seconds. Okay. So here my velocity is going to be 10 less, so it's going to be 10 meters per second, and my time equals 3 seconds. And lastly, here's my ball, where my velocity is temporarily 0 meters per second, and my time equals 4 seconds. So I can go ahead and fill in my velocities here, right? 30, 20, 10, 0. Okay? And we could calculate that. We can use V equals GT, right? So we could calculate this if we wanted. Oh, I was going to leave this here because you can see it, right? G is 10 times 1 is 10, and it has lost a velocity of 10. So this equation really, we shouldn't try to use here because it really only works when we're at rest, and this is not at rest, okay, to start. Now, so we've done show the position, at least so far, the velocity at each, and now the distance the ball rises or falls. To show that distance, we want to calculate our average velocity. And our equation that we're going to use for average velocity is the first velocity plus the second velocity divided by 2. Then, because our distance is our velocity, our average velocity, times our time. So to figure out this distance here, I'm going to take my first velocity, which is 40 meters per second, add my second velocity, which is 30 meters per second, and divide it by 2. Okay, so that gives me 40 plus 30, 70, divided by 2 is 35 meters per second. Now, it on average is moving that speed during that second. So to figure out how far it goes, I'm going to do distance equals my 35 meters per second times my 1 second, which is 35 meters. So I'm okay with, as long as you show this work once, you don't have to show this work every time. So for my next second, one of my velocities is 20, the other one is 30. Divide that by 2. 25 meters per second times the 1 second means now the ball has gone up 25 more meters. Next, okay, we have 10 plus 20, which is 30, divided by 2, which is 15, times 1 second is 15 meters. Lastly, we have 10 plus 0, which is 10 divided by 2 is 5 meters. Okay. So 30, 20, 10, 0, okay, is our velocity. The distance, and again, remember, a positive is going to mean, when we kind of say fall in here, positive is going to mean it's going upwards. Negative is going to mean my ball is going downwards. So here, we've risen 35 meters. Next, we went up 25 meters. And then we went up 15 meters. And then we went up 5 meters. Now, our total distance here, if this is our 0 point, okay, then this would be 35 meters above that in the air. To get this height, though, it's the 35 plus, right, the 25. So 35 plus 25 is 60 meters in the air. So this one, again, it goes up another 15 meters in that second. So 60 plus 15 gives us 75 meters in the air. And it goes up another 5 meters. So now it's going to be 80 meters in the air. So now we're going to do the same thing. So I'm going to kind of draw it over here, but this is my first velocity, which is my 0 meters per second. Remember, this is my time of 4 seconds. Now that ball is going to start to fall back down, right? And here it's going to have a velocity of 10 meters per second. Because now gravity is going to accelerate it, right? Here, okay, gravity was decelerating it because gravity was acting downward and the ball was moving upward. Now gravity is going to accelerate it. So we're going to have 10, okay? Our next one is going to be at 20. And this was a time of 5 seconds. This is going to be 6 seconds. Next, we're going to be at 30 meters per second. Okay? And that's going to be a time of 7 seconds. And then we're going to be back down here, okay, with a velocity of 40 meters per second at a time of 8 seconds. And we can kind of fill this in again, right? 0, so it's picked up 10 meters per second, 20, 30, 40, and we're at 8 seconds right now. Now, notice our numbers are the same that we're going to do for our average, right? It's 0 plus 10 divided by 2 is 5. That's why I tried to make sure, okay, that these balls were kind of at the same spot. So 10 plus 20 is 30, divided by 2 is 15, so 15 meters. 20 plus 30 is 50, divided by 2 is 25 meters that it's going to fall. And 30 plus 40 is 70, divided by 2 is 35 meters it's going to fall on average. So, okay, we were at 80 meters. The difference is now, right, it's falling downward, okay? So, we've lost, the negative here is telling me it's going downward. So it was at 80 meters, it lost 5 meters, so now it's back at 75 meters. In the next second, it fell 15 meters, so now it's at a height of 60 meters. In the next second, it fell 25 meters. So now it's at a height of 35 meters. And in the next second, it fell 35 meters, right? That's what we have right here. And so now it's back at a height of 0 meters because this is our 0. Hopefully you're okay so far. Now we have more time to go, right? So, okay, here's it's going to be a velocity of 50 meters per second, and my time is 9 seconds. My velocity is going to be 60 meters per second. My time is going to be 10 seconds. My velocity is going to be 70 meters per second. My time is going to be 11 seconds. My velocity is 80 meters per second. My time is 12 seconds. My velocity is 90 meters per second. My time is 13 seconds. Okay, and I'm going to 15, so I'm kind of running out of room. My velocity is going to be 100 meters per second. My time is 14 seconds. And finally, my velocity is 110 meters per second. My time is 15 seconds. Right? So gravity's just changing it by 10. So it was going 40, now 50, 60, 70, 80, 90, 100, 110. And again, that's because here now, gravity is going to be accelerating because the force due to gravity is acting in the same direction as the ball is moving. Now, our distances, right? We're going to do our distances the same way. So we have 40 plus 50, which is 90, divided by 2, gives us 45. So it fell 45 more meters. In this next second, 50 plus 60 is 110, divided by 2 is 55 meters per second was the average, and it did that for 1 second. So it fell 55 more meters. Now, I think you can see a pattern. Okay, 60 plus 70 divided by 2, 65 meters that we fell, right? 70 plus 80 divided by 2, okay? Sorry, that didn't work right. 70 plus 80, if I want to do it that way, I have to include my parentheses. It fell 75 meters, so if I want to do that all in one step, I have to use parentheses. So 80 plus 90 divided by 2, it fell 85 more meters, right? Next is going to be 95 more meters. And then, right, 100 plus 110 divided by 2 is 105 meters. So I can fill this in, right? We fell 45 more meters, 55 more meters, 65 more meters, 75 more meters, 85 more meters, 95 more meters, and 105 more meters. Now, we want to figure out our total distance fallen though, right? So, remember we're at 0 here, and we fall 45, so we're going to call this negative 45. All that means is I'm 45 meters below where I started. That's all the negative is telling me, is I'm below the edge of the cliff. So, negative 45 minus 55 is 100 meters below the edge of the cliff. Okay. Negative 165 meters below the edge of the cliff. Negative 240, so 240 meters below the edge of the cliff. 325 meters below the edge of the cliff. 420 meters below the edge of the cliff. 525 meters below the edge of that cliff. Okay, so we did everything it asked, right? We showed the position of the ball at each time interval. We labeled the velocity at each time interval. We showed the distance the ball rises or falls. Okay, and we completed the chart. What is important and can be nice when you answer a question on a test or a quiz is notice that at the same height, the speed is the same, and it falls or rises the same distance. And the question that comes up sometimes on your homework or test or quiz is, if I throw a ball up with 40 meters per second and I catch the ball again, neglecting air resistance, what speed is that ball going to be moving when I catch it? Well, it'll be moving 40 meters per second. All right, the second page of this. A person stands on the edge of a cliff and throws a quarter down with an initial velocity of 20 meters per second. Draw a picture, so I'm just going to do it all at the top here. Here's my person. We throw a quarter. My initial velocity is 20 meters per second. Draw a picture showing the position of the quarter at each time interval, each second, and label the velocity for each time interval, and show the distance the quarter falls as you answer the following question. So we want to know, how far will the quarter go in 8 seconds? So this is my time equals 0 seconds. So here's my velocity, and I'm going to pick up speed, right, because I'm going down, so now I'm going to be going 30 meters per second. And a time equals 1 second. So I'm going to kind of make them a little bit smaller. 40 meters per second. Time equals 2 seconds. 50 meters per second. Time equals 3 seconds. 60 meters per second. Time equals 4 seconds. 70 meters per second. My time equals 5 seconds. 80 meters per second. My time is 6 seconds. I'm going to 8. So now I'm at 90 meters per second. My time is 7 seconds. And next I'm at 100 meters per second. And my time equals 8 seconds. So the question is, how far will the quarter go in 8 seconds? Okay. So again, to figure out these distances, I do that average. So my distance is going to be my average velocity times my time. My time every time is 1 second. To calculate my average velocity, I'm going to take the first velocity, add the second velocity, and divide it by 2. Okay, and because I'm just multiplying by 1, I basically could take that number and write it as my distance. So 20 plus 30 divided by 2, right? 25 meters. 30 plus 40 divided by 2, 35 meters. 40 plus 50 divided by 2, 45 meters. 50 plus 60 divided by 2, 55 meters, right? And there's that pattern. This is going to be 65 meters. This is going to be 75 meters. This is going to be 85 meters. This is going to be 95 meters. Now, that's, though, remember, only the distance it fell in each second. To figure out how far the total is, right, I'm going to add those all up. So 25 plus 35 plus 45 plus 55 plus 65 plus 75 plus 85 plus 95 equals 480 meters. Okay, so our ball fell 400, or our quarter fell 480 meters. C, the person times how long the quarter falls and determines it takes 14 seconds to hit the ground. How fast is it going when it hits, and how high is the cliff? So basically we're going to continue for 14 seconds. So again, here's my velocity at 110 meters per second. My time is 9 seconds. Okay. Here's my velocity at 120 meters per second. My time is 10 seconds. Okay. 130 meters per second. My time is 11 seconds. 140 meters per second. My time is 12 seconds. 150 meters per second. My time is 13 seconds. And lastly, my velocity will be 160 meters per second. My time equals 14 seconds. So how fast? Okay. It is going 160 meters per second, okay, when it hits. How high is the cliff, right? I have to keep kind of doing this, but I can just do that kind of trick, right? This is 105. This is going to be 115, 125, 135, 145, 155. So I can take my 480, and that was to here, and I can add 105 plus 115 plus 125 plus 135 plus 145 plus 155. Okay, and it is going to have fallen, the cliff is 1,260 meters high. So that's how you do those two problems. Have a great day. Talk to you tomorrow.